if we have the same base being raised to two exponents and those two terms being multiplied together, we get the new term has the same base but with the two previous exponents added together. And this makes sense because if we have x squared times x cubed, well, x squared really means x times x, and x cubed really means x times x times x. So what we really have is 5x's multiplied together, or x to the fifth, which is the two previous exponents added together. So consider 2 squared times 2 to the fourth. Well, according to our rule, this should be 2 to the sixth, which makes sense because if we expand each of these, we're going to get a string of 6 2's multiplied together. So 2 to the sixth is a reasonable answer. So this is 2 to the sixth, which is 64. And if we examine something a little bit more complicated, like 3 squared x squared times 3 squared x to the sixth, well, we can multiply these in whatever order we want. So let's multiply the 3's together first. So we have 3 squared times 3 squared. And then we'll multiply the x's together to get x squared times x to the sixth. And according to our rule, this becomes 3 to the fourth. We add these two 2's together. So 3 to the fourth. For our x's, we now add the exponents together, giving us x to the eighth. And then we generally would finish this off by simplifying 3 to the fourth to 81 x to the eighth. Notice that the rule applies each time we have the same base. So here we have the same base, so we applied it to the 3's, and then separately, here we applied it to the x's because the x have the same base.